Okay, let's start. Fine. So, welcome back guys, welcome to NEET World. So, in this session we are going to see the JEE Mains PYQs of Physics. So, in last session we have completed some questions in PYQs, and in this session also we are going to solve some more questions of JEE Mains PYQs in Physics. So, the first question of this session is, a common transistor radio set requires 12 volt DC. Okay, for its operation, the DC source is constructed by using a transformer and a rectifier circuit, which are operated at 220 volt, that is AC. Okay, alternate current and direct current. Okay, so on the standard domestic AC supply. Fine. The number of turns of a secondary coil are 24, then the number of turns of a primary are. So, we know that the voltage and the number of turns are directly proportional to each other, right. So, let me take, yes, yeah. So, what are the given terms here, like operated at 220 volt, that is AC, no. So, primary voltage, which is 220 volt. What about the secondary? Secondary is secondary voltage is 12. This is 12 and this is 220. So, 12 volt. So, they have given the number of turns of a secondary coil. So, the secondary coil they have mentioned, right, number of turns in a secondary coil. So, number of turns in secondary coil, which is equal to 24, right. No, now I need to get the answer, like number of turns in primary divided by number of turns in secondary, which is equals to voltage primary by voltage secondary. I've told, no, like number of turns is directly proportional to the voltage. This is the thing we know. So, I need to find the primary case. So, number of turns in primary should be equals to, what is the potential, that is primary 220, right, no, 220 divided by how much, it is 12. So, 12 into 24, number of turns in secondary is 24, right. So, 1 times and this is 2 times. So, answer is 440, that is it. So, 440 turns, right now. So, the number of turns of primary coil are, that is it. This is the answer of the given question. Okay. So, the thing is, the number of turns and voltage are directly proportional to each other, and we can solve the question. We will go for the next question. Yes. Let me zoom it a little bit. Yeah. An unpolarized light beam is incident on a polarizer of a polarization experiment, and the intensity of light beam emerging from the analyzer is measured as 100 lumens. Now, if the analyzer is rotated around the horizontal by 30° clockwise. So, 30° clockwise they have told, no. So, clockwise direction, the intensity of emerging light will be. So, the total thing I need to find, that is it, no. So, what they have given, 30°. So, theta will be equals to 30. So, I intensity I need to get, I net is equals to I naught into cos square theta. This is the formula, intensity formula. Okay. So, I will be equals to, like I net will be equals to how much? I naught is 100 no. So everything in lumens only they have asked. So 100 I'll keep as it is. Cos 30 is root 3 by 2. Cos square theta no. So root 3 by 2 the whole square. So I will get 100 into 3 by 4, which is nothing but this 1 times and this is 25 times. So answer is 75 lumens. So this is my I net. Okay. Can we go for the next question? Yeah. So is it clear? No, like the images, the questions are visible to you guys, no? Okay. Fine. We'll go for the next question. Yeah. In connection with the circuit drawn below, the value of current flowing through 2k ohm resistor is. So we know that V is equals to IR, where I need to find the current. Now V is equals, I is equals to V by R. So what is the voltage? Let me take this circuit. Okay. Let me explain why I am not taking this. Okay. Let me take this. So they have given 5 volt and it is 2 kilo no 2 kilo resistor, like 2 kilo ohm resistor no. So 2 into 1000, that is 10 power 3. So which is nothing but this 1 times and this is 2.5 times. So 2.5 into 10 power minus 3 ampere. Okay. So now if you see the breakdown current in the Zener diode, no, if it is above 5 volt, it is 0. That's why we are not taking. So we are considering only this. Okay, only this one we are considering, and they have asked follow like current flowing through the 2 kilo ohm resistor. Okay. So answer is 2.5 into 10 power minus 3. So if you want to write in points, 0.0025 ampere. Okay. We'll go for the next question. So the Zener breakdown occurs in PN junction having P and N both lightly doped and have wide depletion layer, heavily doped and have narrow depletion layer, heavily doped and have wide depletion layer, lightly doped and have narrow depletion layer. So these are the like direct questions, no. So Zener breakdown occurs in PN junction. So PN junction will have highly doped, that's one, like heavily doped, and will have the narrow depletion layer, no. So obviously option 2 will be the answer. So heavily doped and have the narrow depletion layer. So the keep in mind whenever we are seeing the Zener diode, no, Zener diode, the breakdown occurs at PN junction. It is heavily doped and narrow depletion layer. Okay. We'll go for the next question. Okay. So an X-ray tube is operated at 1.24 million volt. So to 1.24 million volt, I will write here 1.24 million volt can be written as 10 power 6. Okay. The shortest wavelength of the produced photon will be. So shortest wavelength, like lambda minimum they are asking, no. So hc by ev, this is the formula, no. So what is the value of this? So it is 1240 nanometer, and it is given as, like, X-ray tube is operated at, EV is given as 1 point, electron volt is given as 1.24 million volt, no. So 1.24 into 10 power 6. So from this I can get, like, if I multiply power 3 for this number, no, I will get 1240 nanometer divided by 1240 into 10 power 3, right. So this 1 times and this 1 time. So 10 power 3 will go up, means 10 power minus 3 nanometer. So option 2 is the answer. Right, we'll go for the next question. Yeah. So on the basis of kinetic theory of gases, the gas exerts pressure because its molecule suffers change in momentum when impinge on the wall of the container, continuously stick to the wall of the container, continuously loses their energy till the reaches wall, are attracted by the wall of the container. So which of the 4 options are correct for this question? So obviously, like, are attracted by the wall of the container. No, it's wrong, no. Yeah. So continuously loses their energy till it reaches the wall. No. So continuously stick to the wall of the container. No, like kinetic theory of gases, the gas exert pressure because of its molecule. Obviously no. So option 1, if you see, yes, suffers change in momentum with impinge on the wall of the container. Yes. So suffers change in momentum only happens there, right? No. Okay. The next question is, when a particle execute SHM, the nature of graphical representation of velocity as a function of displacement is, so elliptical, parabolic, straight line or circular. Can you give the answer for this question? We'll see which of the correct option. Yeah, by using the formula also, like velocity as a function of displacement, no. So velocity as a function of displacement in the sense v is equals to omega into root over a square minus x square. So if we see this equation, which of this option will be correct, like parabolic, elliptical, straight line or circular? Yes, obviously elliptical is the answer, right? No, elliptical. So by using the equation only we can say, like, under root of a square minus x square, right? So the next question is, yeah, match list 1 with list 2. List 1 is source of a microwave frequency, source of infrared frequency, source of gamma rays, source of X-rays. And list 2, they have given the 6 thing, like radioactive decay of nucleus, magnetrons, inertial electron, vibration of atom and molecule, laser and RC circuit. So out of the 4 option, I should get the match the following of this list 1 to the list 2. Okay. So first one, if I see source of a microwave frequency, which of the options are, which of the thing I can match from list 2? So radioactive decay, no. Magnetrons, yes. So source of a microwave frequency, no. So magnetron. So A. What about B? Source of infrared frequency. So source of infrared frequency. So second one completed. In this remaining 1, 3, 4, 5, 6. Okay. radioactive decay of nucleus, no. Inertial electron, obviously no. Vibration of atom and molecule, infrared frequency, no. Yes, B, no. This is B. So what about C? Gamma rays, no. Radioactive decay of nucleus, obviously. So this is my C. So source of X-rays, inertial electron, laser, RC circuit. So out of this three, inertial electron for source of X-rays option. So this is D. So for A, it is A should be 2. So option 2 and option 4 I can eliminate. Option 2 A is 4, option 4 A is 4. So I can eliminate. So option 1 and 3 are left out. So for B it is 4. So for B it is 4, yeah. For both of them it is 4. For C, source of gamma rays, C, like that is 1, C 1 they have given. So obviously option 1 is the answer. They have given 4. So I can eliminate 2, 3, 4. So from this, option 1 is the correct answer for the given question. Right? So okay. So with this we will complete the session. So we will bring some more question in the next session of the class. So till then, bye guys, we will meet in the next class.